Hi, on this class we are going to create a small game. It's a shoot 'em up game where you fly a plane and you need to kill the aliens that come from above. The purpose of this game is to teach you how to implement some behaviors to real game assets. So let's get started. Everything we created here, it's working inside this sample scene. The sample scene, it's like a level. It can be the main menu, it can be the intro, it can be the credit page, it can be level 1, level 2, level 3, whatever. In this case, we have the sample scene, which has this camera, the box, and those scripts we did before. But now we are going to create a new scene to build our game. So let's right click on scenes, create, and we select scene. And we will call it level 1. We can open level 1 and here it is. It's empty, it only has the camera and that's it. To create our level we will need to have some sprites, which are the images, and we need to have some scripts to control those assets. So let's get the images. So here in my desktop I have here a folder that has two images. This will be the background of our game, and this will be the assets of our game. They are all inside the same image. So let's import this to our game folder. Copy. Inside Unity you can go here, assets, right click, show in Explorer. Let's create a new folder called Sprites. Inside the assets, sorry, wrong place here. So we need to have a folder called Sprites, and then here we put our images. When we go to Unity, Unity will import those images. We have here this that contains all the assets we need, and this one with the background. Because this is a pixel art game, we need to have the game a little bit more sharp, let's say. If I zoom in, you can see that these are not very sharp. They are a little bit blurry. This is happening because here on the settings of the sprite, the filter mode is bilinear, and you can change to point, no filter, so it will render without trying to blur the edges. So this it's sharper. We will do this for this game sprites sprite, and for the ground also. So bilinear goes to no filter, apply. Okay, let's remove this from here, delete. Another thing related with the sprites is how can we separate all of these assets that are inside only one sprite. When we select a sprite, here in the inspector you have up here the sprite mode. The sprite mode can be single if this is only one image, or you can use multiple if it has multiple images inside. And after you do this multiple, you need to apply. It's hidden here. Apply. And now you need to go to the sprite editor. This will open a new window. And in the sprite editor you need to select exactly what are the images. In this case I'm selecting the player, so one. I can select and adjust later, so I don't need to be right the first time. This will be player forward, player forward. Here will be player right, player right. So this one will be player left, I guess. Player left. Player left, player right, player forward. Apply, and here you have created 3 new sprites from this texture only. So if you go on Unity again, you close the window, you go on Unity, and inside this sprite now you have these 3 sprites here. Now let's talk about the camera and how can we control the pixel per unit setting in the sprites. This is very important. If I drag this ground to the scene, you can see that this doesn't fill the screen. It should be something like this. Let's scale it manually. Okay, but this is not the correct way of doing it, because you are technically scaling up the asset. So now this asset is 700% in size. This means that probably the speed and the timings and the weight and everything else will be scaled also. And if you have one asset inside another asset, if you scale this one, you will scale eventually the others. So avoid scaling things. This should always be 1. 1 means 100%. The size times 1, so the current size. We should adjust the pixel size to fit our screen. In this case, we need to understand how the camera works. So the camera has here a size parameter. This parameter says there is the vertical size of the camera view. Well, more or less, it's not the vertical size of the camera view, it's half of the vertical size of the camera view. Because you can see it's 5, but if you zoom in, you can count 10 squares. So from the center to the top, you have 5. We need to do some math to understand how many pixels we need per unit to fit this camera. Okay. So first of all, we need to understand the proportion of the camera. In this case, we have a 16 by 9 aspect. If in your computer is free aspect, change it to 16 by 9. For example, if the camera has exactly 4.5 in height, it has 16 in width. Why? Because if this is a 16 by 9 camera and the height of the camera is 9, because it's 2 times 4.5, the width will be 16. So now the question is, how many pixels fit inside one square only? Now Unity is set to put every 100 pixels inside a square. So we need to put less pixels per square so we can spread more the image. And to do that, let's do more math. 256 pixels divided by 16 meters gives us 16. So if we set the asset to be 16 pixels per meter, the image should have the precise size of the screen. Let's apply, and boom, it's there. Okay, so if we are using this number to set up the size of the image, so how many pixels per unit, how many pixels per meter we are rendering, well, you can be here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 pixels per meter. So if this is 16, this also should be 16. Apply, and there is 16. So now the plane has the right size. We see that this is behind the background, so let's put in front of the background. To do that, inside the sprite renderer, in the ground object, in the player object, or in any object that has a sprite renderer, you'll have here order in layer settings. This means if it's rendered before or after something. If this is our player, this should be 0, at least that's how I work. Player is always 0, and now I define what is behind the player and in front of the player by using negative or positive numbers. So now the player, let's move, it's here. Okay, I'm outside of the camera, I guess. Yes, I am. So this is the camera. You can see the render. This is what the camera will see. So what you are going to see when you are playing full screen. I want the player to move this direction, and when it moves to the right, it changes the image to this image. And when it moves to the left, it changes to this image. So let's create a new script. Create new C# script, and this will be called player movement. Okay, player movement, enter. This player movement will control only the movement of the player. Then we will create another script to control the sprites that we are using inside the player. When we use this technique of having small scripts to control small things, you can have an object with 50 scripts, but at least you know where the things are, and if you need to improve, remove, update or correct something inside one behavior, you don't need to worry about the others. Technically they are separate, so the scripts will not have variables that interfere with each other, will not have a lot of stuff that can be messed up if you start deleting things to arrange something, and then you can destroy another behavior by accident. So one way of solving that problem is don't do everything inside the same script. Keep the scripts clean and simple, so it's easier for you to understand what they are doing. The name clearly explains what they do, and if you need to use this in another object because it's the same functions you need, you can just drag there. We will do that later with other things. For now, let's edit this player movement and let's start coding something to make this plane go left, right, up and down, and let's see. So let's deal with the speed first. Public float, let's say forward speed equals 1, I don't know. Public float side speed equals 3, I don't know. We can change these numbers later in the inspector, and then we need to limit the screen. We need to limit the movement inside the screen, so let's do some public float x minimum equals, I don't know, -2. Probably will be more. If the screen has 16, it should be like -4, 7, 7 or 8, something like that. Public float x maximum equals 7, and then to the y axis let's use public float y max equals 4 and public float y minimum equals -4. So this should be the numbers we start with, and then we change them later if we need. Inside the update function, so every frame, we need to do what? We need to make sure that we don't have any direction, as you remember from the last class. So let's say x direction equals 0. Well, this x direction is not declared, and because I don't want every frame to declare a variable, to create a variable, let's create it here. X direction, this needs to be a float. Float x direction, we don't need to put the number yet, and another float y direction. So in this case I'm declaring the variable here is a float type and it's called x direction, but I'm not assigning any number. It's not necessary because the first thing computer will do every frame will be set up that number to 0, so I guess it doesn't need to be there. Y direction equals 0. At the end of the frame we will move the object. Transform dot position increment plus equal to a new vector3, and this vector3 needs to have 3 numbers inside, x, y and z, and now we multiply that by time delta time. Why? Because we need to adjust the speed of the movement to the time it takes to render a frame. That's what this does. So position increment to 0, 0, 0, so it doesn't increment. So we will change here the direction x, direction y, x direction, the y axis will be y direction. Okay, we need to multiply this by the speed because we have different speeds. So forward speed will be y times forward speed, and the x direction will be times side speed. As you can see in the previous class, I use a game object. Inside the game object we call the transform and position. Here we are calling the transform directly. And why? Because technically we don't need to call the same object. If this script is inside the plane, we don't need to say plane.transform.position. If the script is inside the plane and we talk to the transform, it's a direct route. So it will transform the plane transform. Inside Unity we have the player movement, and this player movement, if it talks to a transform, it will talk to this transform specifically. Okay, and this is the only component that it does that. This is the end game object, I guess. So if in my script it has transform, I'm talking to that transform directly. I don't need a variable, I don't need to call for that component, it's done. So I'm not going to use the get key as I did in the last class. That was one method of getting information from the user. Which key are you pressing? In this case, I'm going to use another way of doing it. If you go here on Edit and you open the project settings will appear as a floating window. Project settings will appear as a floating window, okay? And it has all of settings of your game. I like to dock this window here next to inspector. Come on, next to inspector, okay? So it's there. Every time I need it, I don't need to open and close, etc. And inside this project settings, you have here the input manager. If you see this warning over here, this is where you can configure the controls to use with the Unity Engine Input API. Consider using the new input system package instead. Yes, if you are making a game for the future, consider using the new input system package instead, but because you are learning on how to use Unity to make a simple game, this will be a much clearer and simpler approach to do that. Okay, once you understand this, you can try the other one, but because the other one is more complex. The other one will be the future. Eventually this one will be removed, but for now this input manager allows you to create access of control. It has 30 access by default. I can, for example, if I create 31, now I have here another one, and I can call it whatever I want to call it, and I can set the keys. I think they need to be there, and whatever these settings do. And now in my script, if I call this name, I can have these keys working. Okay, so we are going to use these default ones, the horizontal and the vertical. The horizontal, as you can see, it's called horizontal. Negative button is the left key, positive button is the right key, alternative negative is A, alternative positive is D, and this is the time it takes, time in units per second. So how many units per second it takes to go to 0 when you release the key. This number is fine. And if it has a dead zone, it's here, sensitivity, snap, if you want to snap or not. So we are going to use the input manager, and we are going to use the vertical and the horizontal axis. Instead of input dot get key, and then you specify the key, instead of doing this, because this will be only this key and it will be only on or off, we are going to get another thing, get access. And now we specify the name of the access. Input get key is a boolean. It returns a boolean, it gives you true or false if you are clicking or not on the key. The get access will return a float. It will give you a number, a positive or a negative number. If it goes to negative, it goes to -1. If it goes positive, it goes to 1. If you don't do anything, it goes to 0. And between 0 and 1, all the decimal places possible. So if you are using a joystick, an analog wheel, whatever it is, it will give the intermediate positions also, not only on or off. Technically, I can just use this because this is a number, 1 and 0, -1, 1 and 0. I can use this inside here directly. If I do this, it will move. The question is, if I want to limit the movement, I need to have something to limit that movement, and that's why I'm using the X direction anyway. So this don't go here. So how can we do that? Let's test if we are pressing the keys and if we are inside the screen size, and if that is viable, we can change the direction. Okay. if now we need to have two things to get. We need to see if we are touching the keys. So input dot get axis horizontal so if we are getting horizontal higher than 0, remember this get axis is not a boolean, it's not true or false, so we need to test against a number, a value. It's a float, so we can test it against 0. If it's higher than 0, this means that I'm pressing the right key, and my position, transform position, now I will specify an axis. So, and transform position x is less than the maximum. So let's say maximum is 7. So if I'm pressing the right key and my position is less than 7, I can go to the right. And to go to the right, I will just x direction equals, if we press to the right, we will put that value inside the direction. And of course, if we are inside the screen. So now that I have this to the right side, I can go to the left in the similar way, just changing here the numbers. So if it's less than 0, because I'm clicking on the left side now, and I'm higher than the minimums, again, I put the x direction equals to what I'm feeding to the computer. So this will make the thing goes left and right. Save, and let's save and see. The thing goes left and right without going past here and past here. So let's see, player forward, let's go to the inspector. I can adjust these numbers later if I need. So +7, it's here, I guess. No, it's here, so it doesn't go further than this. And to the other side is this. Let's see. Play. Left. Stop. Yep. Right. Stop. Yep. Okay, this is working. It can go faster. Let's change here some numbers. So side speed, let's put 6 meters per second. Forward speed can be 5 meters per second. That's it. Let's work now on the y-axis, which is exactly the same thing. We just change. Let's paste. Here is vertical. Now we are going to test the vertical axis. So this first one is if input get axis vertical is less than 0 and transform position y is higher, is greater than minimums, y min needs to be y direction will be equal to y axis, vertical axis. So this is how I go down, copy, paste, and this is how I go up if it's higher than 0 and less than the maximum. Okay. You should comment this if you want. So this is going right. going left, going up, no, down, and this is going up. So in 5 months, when you look at this, you know what the purpose of this line over here. Let's see, apply. Let's make sure that we have the correct directions program, so it doesn't go further than this. It needs to be a little bit less. See, it goes to -4, but the plane is outside of the camera, so I guess it needs to be 3 point, like here, so 3.5, and to the other direction should be also be 3.5. So let's change this y max to 3.5, y minimums -3.5, and that's it. So it stays inside. I have here these images: forward, left, forward, right. Okay, so let's change the images inside. This is the player object, and here we have the sprite renderer. So if we change the image here, let's say left, if we put the left here, now the plane looks like it's turning left. Play forward again. Okay, so let's do this automatically using a script to control this according to our axis. So let's create player forward. Let's create a new script. Create. Inside the script folder, right click, create C# script, and let's call it player sprites. Player sprites. Okay, let's drag the player sprites inside the player. This is called player forward because I just dragged this image there, but now you can change the name of the object. Doesn't affect anything. Let's say player, only player. Player has here the player movement. This script is only to move the player, so we can close it and forget it. It's working, so we don't need to worry about it. Let's open this player sprites and let's add here the code we need to change the sprites. So one thing we will need is to know which direction we are going to move. And to do that, we are going to use the get axis horizontal. So if input get axis horizontal, it's equal to 0, we change the sprite. Here we are going to change the sprite to forward. But to change the sprite to forward, we need to tell the script two things. What sprite are we talking about? So we need to tell the sprite, and we need to tell which sprite renderer we are going to put the sprite on. That's how it works. So this sprite needs to have a reference to this and another reference to that. And inside that we are going to call this one over here. Okay. To do that, let's start with the sprite renderer. How do we call the sprite renderer? Inside the script, we need to have a variable to put the sprite renderer. I will use a public one just to show you one thing, but these don't need to be public, of course. Public what? It's a float. Is a int, is a boolean, which kind of variable it is? Well, if I'm trying to talk to another component, the type of the variable is the component itself. So, which type it is? A sprite renderer? Well, it is a sprite renderer. Sprite renderer. So this is the type of our variable. It's the component itself, and it will be called sprite renderer, sRenderer. So I will use a different name so it doesn't interfere with the sprite renderer. Okay, empty. I will not say equals to something because I cannot write what it equals to. So if I save, let's go to Unity. As you can see here in a bit, now I have here one variable called sRenderer, and it's none, doesn't have anything. Okay, I can pick up this renderer and drag it here. Okay, this is a way of putting here the renderer. Now the script knows that when it's talking to the sRenderer, it's talking to this thing, which is that thing. Okay, but the question here is, we don't need to do this manually. Okay, we can set this script to find automatically this sprite renderer. So let's remove none. Okay, we don't have anything yet here. Let's set the script to find the sprite renderer automatically. To do that, inside the start function, we are going to say sRenderer it's equal to, now let's get that component over there. So get component, inside this, inside here you put the name of the component you want to get. So sprite renderer, and with no arguments, and you close this statement. So this, what is going to do? It's going to put inside this variable a component called sprite renderer, get the component. Is getting this component from inside the same object. So that means that is going to look at these components over here, and it will try to find something that is called the sprite renderer. Well, it's this one, so this one will go there. Let's save, and let's test it so you can see this working. Nothing happened right now because this is not running. See, it's still none. But if I hit play, you have here automatically the player sprite render. So the sprite render there is inside the player object, so it's the same player object as the sprite renderer that is there. If I click here, it will signal the player, and the player has this sprite renderer, so this sprite renderer is that sprite renderer. Okay, this is how this works. If I stop the game, this renderer disappears from here. That's okay. So this is how you do it automatically. You create a variable for the component you need with a name you want to use, whatever the name you choose. You set it to the type of the component, and then first thing to do is to get that component and put it inside the variable. So now every time I talk to the sRenderer, I'm talking to the sprite render of the player object. So let's say if getAxis horizontal is 0, let's put the forward image inside this renderer. So sRenderer, Now I need to talk to sRenderer dot sprite, so I can change the value. If I want to change, for example, the flip, I should say sprite render dot flip dot x equals true or false in this case. So sRenderer dot sprite is equal to forward sprite. Okay, but if I save this and go to Unity, it is going to throw me an error saying, I don't know what you are talking about. I don't know what is a forward sprite. You didn't define it. Okay. So we have here a variable to identify the renderer. Now we need to have more three variables to identify the three sprites that we need to use inside the renderer. So public, this will be sprites, so public sprite, okay, and this will be called forward sprite, and we close. So this forward sprite is this forward sprite, and we put the sprite there manually. So when we go 0, we say forward sprite goes to the sprite renderer and it renders that sprite. Let's save. Oh, let me add the other two. Public sprite, left sprite, come on. Sometimes this happens, so careful with this auto sprite. If it's suggesting and you click on space, it will write this. This is, you need to click on escape. Stupid behavior. Public sprite escape write sprite. So now I declare three variables to put the sprites inside, and then in each case 0, minus, then 0, and plus, then 0, I will change accordingly. Let's save. Let's go to Unity so you can see it here. So sRender will disappear, I guess. Yeah, because it's not public anymore. It doesn't need to be public. So forward sprite, none. Which one is the forward sprite? Is this one, player forward. Goes there. Left sprite will be the player left, and the right sprite will be player right. So now this script knows what is forward sprite, left sprite, and right sprite. Is this ones over here. So if input get axis horizontal is 0, it will set up the sprite renderer to forward sprite. Now let's copy paste this 2 times, sorry. If horizontal is less than 0, so it will be left side, we are going to set up the sprite of the sprite renderer as a left sprite, and same thing for the right. So if it's greater than 0, this will be right sprite. Yes, right sprite. Save, and this should be working. Not efficiently, but it's working. Play. So if I go right, it changes the sprite, and now it looks like the plane is turning a little bit. Okay. If you look here to the inspector, you see this sprite variable changing. Left 0, right 0. But what's happening right now, I'm not doing anything, and technically the script is changing the sprite to the forward sprite all the time, all the frames. Well, we can check if we are already using the forward sprite, and if we are already using the forward sprite, we can just don't do it. Okay, so if input horizontally 0, so if I'm not touching anything, and now we test if it's the forward sprite that is there. S renderer dot sprite is different from forward sprite, you change. So what's happening here? If you don't do anything and the sprite is not forward, you change to forward. The next frame, if you don't do anything but the sprite is forward, so this will be false, it will not change anything. So we can use the same technique, copy, paste here and here. Here, instead of forward sprite, we are going to test left sprite, and here we are going to test right sprite. So it only changes if it's not there. If it's there, it doesn't change. So to put the background to move, we are going to create a small script that will do this. We'll put the background over here, and it will slowly make the background go down to give us the impression that we are moving forward. We are not going to move forward with the plane. The plane will stay inside the camera stays fixed. What is going to move is the world goes down. Okay, right click, create C# script, let's call it ground movement. Ground movement, enter. So this ground movement goes to the background. Ground movement drag to the background. This controls only the background, so it will talk to this transform over here that belongs to the background. And what do we need to do? What do we need to do? We need to move it, yes, but it cannot go outside of the screen also, so we need to have some limits. Let's say a start position and a hand position, and probably a speed, I guess, and then we just move that speed till it reaches the end. So like 3 or 4 lines of code, let's say. Let's create the variables. Public float start position equals to, I don't know, 10, I guess. We need to see where it lands in terms of X and Y position. And public float end position equals to -10. I'm assuming that if it goes down, it goes from positive to negative. Okay, now we need the speeds. Yes, speed. Public float speed equals 1, I guess. Now let's make the thing move. Every frame it moves a little bit, so every frame will transform position will increment plus equal a new vector 3 with three variables, 3 values inside, x, y and z, and we will multiply that by time, delta time, to adjust to the frame time. So it keeps the speed independent from the frame rate of your computer, and that's it. Well, it's 0, so it doesn't go anywhere. It needs to go minus something to go down, but this minus something is the speed, so we can change it inside the inspector. So let's go down speed, but this is not going down. If it's 1 and I'm incrementing, it goes up, so it needs to go down. So instead of plus equal, we go to minus equal, and that's it. It goes down. Let's see. It doesn't have limits yet, but let's make sure that it's going down, and we can adjust the variables. So beginning is here. This is the beginning. I'm at 27.4, so the end will be minus 27.4, more or less. Minus, this is the end, minus 27.4. Okay, so start position 27.4, here will be minus 27.4, speed 1. Let's see if speed 1 is too much or not. Save, play. Yeah, sounds okay. Looks okay. I'm flying the plane, flying over the desert. I don't know. Seems okay. So let's stop, and now let's limit the movement. How can we do that? We can do that as we did the player movement. So if we are going down and we are inside the maximum value or the minimum value, okay? So here is the same thing. If, let's say, if here we don't have direction, we don't have keys, so we just need to test if we are inside those minimums, the start position and the end position. So if transform position y is higher or equal to end position, and transform position y is less or equal to start position. So if our position is higher than the end, so higher than minus 27, and lower than 27, so we are between 27 and minus 27, if this is true, if we are inside those numbers, it will move. Oh, before test I will do something else. I will make sure that when we start, the position of the background is in the start position. So let's say transform position, I will copy this. Transform position, it's equal to 0, start position 0. So 0 on X, start position on Y, and 0 on Z. Close this statement. And that's it. Save. We should have a background moving down and a plane looking like it's going up, but doesn't move technically. Control P is the shortcut for this key over here. Okay, looks like I'm going up. It's moving, so the code is correct. Let's see if it doesn't go below -27. Let's increase the speed so this is faster, and it should stop right now. Yeah. So next video will be about creating the shooting system and putting the aliens coming down and shooting at us. So see you there.